Mosquitoes are important vectors of human disease. This seminar is going to focus on controlling mosquitoes to protect human health using mosquitocidal Enzeco chips. My name is Phil Kaler. I'm a professor emeritus in the entomology department at the University of Florida. And I'm also one of the inventors of the mosquitocidal Enzeco chips. Let me give you a little bit of background for this lecture. Mosquitoes are important vectors of human pathogens. For instance, Aedes mosquitoes are the main vectors for dengue, Zika, and chikungunya, which are important diseases throughout the entire world. Culex mosquitoes are important vectors of West Nile virus and other encephalitis. And the Anopheles mosquitoes are best known for their transmission of malaria. We did an integrated mosquito management project that I want to talk about that included education, biological control, which included turtles, fish, and copepods, which are important predators of mosquito larvae. And also we used the mosquitocidal Enzeco chips and stickers because they are very friendly to the environment and also very effective in controlling mosquito larvae. Let me first tell you a little bit about the Enzeco chips, which are designed to kill mosquito larvae before they turn into blood-sucking adults and are an environmentally friendly way to kill mosquitoes. The chips kill mosquito larvae in virtually any container. They have an insecticide coating that is in a polymer to stabilize and slowly release the insecticide over time. The insecticide is actually pyriproxyfen, which is an insect hormone, not at all related to any of the hormones in our bodies, that will kill mosquito pupae before they develop into adults. So these chips can be used for treating any mosquito breeding containers, and the insecticide polymer coating will kill immature mosquitoes over time. And we found that it kills those immature mosquitoes for at least one season or at least 3 months. The most interesting thing about the Enzeco chips is how easy they are to use and apply. All you have to do is drop a chip into any container where mosquitoes may be developing. The larvae hatching from eggs die when they pupate, and the chips prevent the mosquitoes from developing for 3 months. So for instance, on the right-hand side, I have the life cycle of an Aedes mosquito, which is important for dengue and Zika and chikungunya transmission. They will lay their eggs in small containers like pots and bird baths and any small container that you have around the house. And the larval stage will develop to the pupal stage in about 4 to 5 days, and then remain in the pupal stage for 1 to 2 days. It's during that time that the mosquitoes die, and then you have control of the mosquitoes. You don't really care about the mosquito larvae in the water. What you really care about are the numbers of adult mosquitoes that are there biting, sucking your blood, and possibly transmitting disease. We decided to test the Enzeco chips in cooperation with Operation Blessing in Honduras. Now, Operation Blessing is one of the largest charities in America and provides relief in 39 countries around the world. I happened to meet the CEO, Bill Horan, a few years ago at a meeting in Washington, D.C. When I explained the chips to him, he said he wanted to see how they worked himself. Now, Roberto is a research scientist who went with me to New Orleans to treat the vases in cemeteries there. And you can see Roberto standing with Bill Horan. And Bill said he wanted to learn how to use the chips. I told him he really didn't have to fly to New Orleans from Norfolk, Virginia to use the chips. They were so easy to use. So there he is. He flew to New Orleans, wanted to drop chips into containers by himself, and he absolutely loved it and said, why don't we do a research project in Honduras? we decided to test the Enzico mosquitocidal chips in Monteverde, Honduras, which is a suburb of San Pedro Sula, which is the second largest city in Honduras. It has a population of over 750,000 people. At the time, they were fighting a deadly dengue fever outbreak that is transmitted by mosquitoes. They were also fighting Zika virus, which is transmitted by mosquitoes. And they also had a great fear of chikungunya, which was an epidemic situation there in Honduras. And you can see on the lower right-hand side some of the roads in the city of Monteverde. One of the most interesting things about Monteverde is that they relied on weekly water delivery for drinking water in the town. And what would happen would be a truck, as pictured there, would drive up with a large container of water and then give it out to people once a week on Saturdays. And people would come with their own containers and take that water home and store it. Now, when we surveyed the number of mosquito eggs in those containers, what we found was that there were large numbers of mosquitoes laying eggs in those containers. And we often say that more than 10 eggs per container is too many. And we were having hundreds of eggs found in virtually every container that we sampled. Of course, since they're bringing water only once a week, they have to store it in containers. And virtually the entire town was covered over with small containers of water that were capable of breeding mosquitoes. And you can see on each one of those pictures the numbers of containers that are found around the town that are breeding mosquitoes. So they had large numbers of mosquitoes because they had large numbers of containers that were allowing the mosquito larvae to develop into adults. But the mosquitoes didn't only develop in those small containers used for storing their water, they also developed in their wells. And there in Honduras, what they would do is hand dig a well for irrigating their crops or their small plants for food. And they would line the sides of those hand dug wells with tires, which is a high-rise condo for Aedes aegypti mosquitoes, which are the prime vector of dengue, chikungunya, and Zika virus. So you can see the water in the bottom of the well there, and each one of those tires then retains enough water to allow mosquitoes to develop. Mosquitoes not only develop in small containers and tires around the wells, but also they develop in pilas, which is a water storage system for a house. It usually is a combination of bathroom and kitchen sink, and also laundry that we would have in the United States. So there's a picture of a pila and the way it is used by a woman cleaning dirty pots and pans on the right-hand side. We felt that in order for our program to work in preventing mosquito development and also in preventing disease transmission, that Operation Blessing and University of Florida would have to do an integrated mosquito management program. So in that program, we trained volunteers. There on the upper right-hand side, you can see that volunteers are being trained by a member of the Operation Blessing staff there in Monteverde. We also used the Enzico mosquitocidal chips and stickers there in the lower right-hand side. The total integrated mosquito control program in Monteverde also included copepods, which are important predators of mosquito larvae in containers. Also turtles, which can feed on mosquito larvae, and top-feeding minnows, which are fish which also feed on mosquito larvae. So we felt that biological control could also be implemented to supplement the action of the chips in the control program. Sometimes in the community, it's very difficult to educate adults, and it's much easier to educate kids. So we implemented an education program of school kids in the program for biological control of mosquito larvae, how they develop, where they develop, and how they would be managed in the community. So there are some kids that have gone through the training program. They actually colored in pictures of fish and copepods and turtles for them to understand the importance of all of these in mosquito management. To overcome the problem of language, what we were able to do was come up with data sheets to be able to document where mosquitoes were present, where the turtles were present, where the biological controls were present, and most importantly, where the Enzico chips were present in containers throughout the community. So on the left-hand side of the sheet, you can see in the colored sheet on the left that we had pilas and containers and all sorts of places where the mosquito larvae would develop. And then on the top side there, you can see that they could mark down whether turtles were present or fish were present or chips were present in those containers. On the right-hand side, that's one of the evaluation forms that was filled out. And on the top there, you can see in the Pila, they had found turtles and they had also found the fish there as well. It's important for all of that to be documented as part of a research program. Just a little bit more on the chips that we used in this program. You can see that the Enzico mosquito chips are currently in development to be sold throughout the world, and they contain polymer-embedded mosquitocide, which contains pyriproxyfen. And you can see in the package on the right-hand side that they are known to last at least 3 months and provide about a season's worth of control in most cases. The things that we found out in this program was that the chips need to be glued to containers where people are pouring the water out of the containers to be able to use for drinking or for cooking, that the chips then would fall out of the containers and be lost, or they needed to be dropped into tires and in the well that surrounded the wells. So it was quite a laborious process to get the chips into the tires. We eventually found that if we took a piece of PVC pipe and slid the chip down into the tire deep in the ground, that was the easiest way to be able to treat them. And you can see on the left-hand side that just taking a hot glue gun and being able to glue the chips to the sides of containers kept them from being lost when the water was poured out. And then on the right-hand side, you can see a volunteer looking in the tires to apply the chips. Because gluing the chips to the sides of containers can be very laborious and difficult to do, we decided to develop mosquitocidal stickers which do not need to be glued and still adhere to the sides of a container even underwater, that are actually stickers which will adhere to the sides of containers underwater and release the insecticide into the water. To verify that the stickers and chips that contain pyriproxyfen can actually kill the mosquito larvae for months, what was done was we had containers that had mesh bags over them for the mosquitoes to emerge, let those containers float in water that had been treated with the stickers and chips, and determine whether they worked. We found in that particular test that these stickers and chips will kill mosquito larvae for months after placement. We also wanted to know whether the mosquitocidal stickers and chips would repel mosquitoes from laying eggs in containers that were treated. So what we did was we had a choice test where we had one container that was treated, another container that wasn't treated very close to it, with paper on the side where mosquitoes like to lay eggs. And then we could see whether the mosquitoes laid as many eggs in the treated containers as the untreated containers. What we found was that the mosquitoes were not repelled by the presence of the stickers or the chips in the water. And that's important because what we want to do is have the mosquitoes lay their eggs in containers that are treated and then die, as opposed to going to other containers, laying their eggs and then developing, and then possibly those mosquitoes that come off would be capable of transmitting disease. The insecticide in the chips and the stickers is pyriproxyfen, which is a synthetically produced insect hormone, has virtually no harmful effects on humans or other mammals, and produces pupal and adult defects due to exposure of the larvae and the pupae in treated water. So for instance, on the top four pictures there, you can see some of the deformities where adults are unable to fully emerge from the pupal skin and even remain in a larval stage that does not turn dark like a normal pupa would do. And then also sometimes adults would emerge that were completely deformed, not capable of flying and not capable of sucking blood and transmitting disease. In this integrated program, we also released turtles and fish, as well as treating almost all of the containers with chips and stickers. And the results of 1 week's efforts in turning loose turtles and fish were 150 fish were dispersed to 80 homes in Monteverde, and also 15 turtles were placed into wells and pilas to help control mosquito larvae. So the copepods were released into tires, and on the left-hand side you can see a copepod actually consuming a mosquito larva. And on the right, you can see the way that the volunteers were able to release the copepods just with a small pipette. They could insert them into the tires in order to control mosquito larvae by predation of larvae with the copepods. To see whether the copepods survived the transfer into the wells and tires and cisterns, we had volunteers who would go out and observe them in wells and tires. And what we found was that the cistern design didn't allow us to be able to monitor afterwards. But basically, the copepods survived in the wells and the tires, and we don't really know if they survived in the cisterns, but we expect that they did. So we were able to do sustainable container mosquito control in Monteverde. In Monteverde, our integrated mosquito management program was the mosquitocidal chips and stickers that were placed in virtually all of the pilas, drums, buckets, and cisterns throughout the town. Copepods were placed in wells and cisterns and drums, and the turtles and fish were placed in wells. The chips and stickers we know worked for about 6 months in that particular situation. And the Enzico chips and stickers are in the process of being developed for people throughout the world in this point in time. Our sustainable mosquito control program was a huge success in Monteverde, Honduras. The chips not only controlled mosquitoes, but they helped eliminate mosquito-borne disease in the town. The disease in Choloma, which is the area surrounding Monteverde, had 71 dengue cases, 3 Zika cases, 1 chikungunya cases. So they had mosquito-borne epidemics going on in the area. However, within Monteverde, where we had done the applications of the chips and the stickers and the turtles and the copepods and the fish, we had no dengue, no Zika, and no chikungunya during the program. So if we summarize some of the points in this lecture, we know that mosquitoes are important in transmitting mosquito-borne diseases. So for instance, Aedes mosquitoes transmit dengue, Zika, and chikungunya virus. Culex mosquitoes transmit West Nile virus and other encephalitis. And of course, Anopheles mosquitoes transmit malaria. In Honduras, we took on Aedes mosquitoes through an integrated program which included education, biological control with the use of turtles, fish, and copepods, and we utilized a very environmentally friendly form of control with mosquitocidal Enzico chips and stickers. The mosquitoes were controlled and the diseases were eliminated. If you would like to learn more about the Enzico products, go to inz-eco.com on the web to find out more information.